Here we go. Welcome to statistics. So number one, what is statistics? Statistics is generally broken into two areas. We've got descriptive statistics and then we have sorry, I'm a little nervous first day. My mind went slightly blank there. Inferential statistics. And descriptive statistics is just like it sounds, it's describing data. So generally with descriptive statistics, we are summarizing data. And what is data? Data is just some kind of information. So bits of information. And by bits, I mean some little small chunk of information, like my name's Gary. I teach math. I'm 5 feet 8 inches tall. I'm going bald. I like to mountain bike. And I love doing math professionally and for fun. Right? Those are all pieces of data about me. But data could be something else. Like it could be data about a country, like the United States. The United States is in the Western Hemisphere. It's in the Northern Hemisphere. The United States is made up of 50 states plus some other things that are like states, but we don't quite give them the rights of states. There are 380 million people roughly right now in the United States, if I remember right. So data could be about a person, a place, a thing. And it's just a chunk of information. And then we try to summarize that data. How do we summarize that data? Well, we summarize that with calculations. And any calculation you do on data is technically called a statistic. So the word statistic has a general meaning and a more specific one. So generally, it means describing data or making inferences about data. And then specifically, a statistic is a calculation from data. Right? Examples of calculations from data that we use. One of the most commons is average. The most basic really is count. How many? Like I just collected data on you all. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 people gave me information on that data. I was hoping for 25. I got 20. That's okay. Let's see, I asked about degrees. That's data. Now, I can't find the average degree, right? I could find the average age of you guys, right? That makes sense. What does average degree mean? Average means add them up and divide. How can you add up degrees? You can count them, right? So the idea of count is special in many ways because for some kinds of data, that's kind of all you got. But I could take that count of degrees a little farther and I could say what percent of you are getting a science type degree versus what percent of you are getting an arts type degree, like AAOT, Associate of Arts. How is that different from an AS, Associate of Science, or an AAS, Associate of Applied Science? Well, some of them have the word science in them and some of them have the word arts in them. That must mean something, right? So anytime we look at something like a percent, it's technically called a proportion. So that's another kind of count we might make. Have you heard of the word mode? Anybody remember what mode means statistically?
most often.
Yeah, it's what occurs most often. So I could say like what degree occurred most often, and it looks like it's a toss up between an AS and an AOT. I'm not sure. I'll count them later. Um, but mode for age, it's possible everybody has a different age, right? Especially if we went for fractions of a year. Okay, so mode makes sense with some kinds of data, but not with other kinds of data. Average makes sense with some kinds of data, but not other kinds of data. So we're going to get used to when we can do different statistics depending on the data type. So that's something big we're going to play around with. Other things we'll do besides calculate these statistics are make charts and graphs to visualize the data. Sneak that in here. Visualize with charts and graphs. And most of chapter 1 is definitions like this, which is kind of dull. So I'm going to sneak in a little of chapter 2 where we actively get to do some statistics today. So we're not going to quite finish chapter 1 today before we start chapter 2, which is all right. Let's see, I heard a new ding dong online. Who do we got? Whoa, that was interesting. Emily, did you just drive online, Emily?
Yes.
Okay, hi Emily, welcome. Let's see, Emily, which section are you in? You're in the Pendleton section. I hope you come to Pendleton someday. We're in Emigrant Hall when you can get here. What degree are you seeking, Emily?
AAOT.
AAOT, thank you for more data. Cool. All right, let's see, back. Where are we? I was describing what the hell descriptive statistics is. So it's summarized data using statistics, calculations, and visualizing data with charts and graphs. So this week and next week, that's mostly what we do. And then in the third week, we're gonna kind of, it's a blend of descriptive and inferential. What's inferential statistics? Inferential statistics is making predictions based on data. And I am going to go look online for prediction based on data right now. Let's see, I want my browser. And then politics has been hot in the news lately. Not always, but right now it is. And I was looking up at, I wasn't looking, I was curious about residential approval rating. Okay. What do the latest polls show? Let's see, don't make me log in, please. Oh, they want me to disable my ad blocker. Come on, give me a number. Okay, here we go. March showing 48% approval rating, 46 disapproval, dropped a little bit. Other polls show 51% approval rating, 48 do not approve. Depends on where you look for that data. Did they ask you? No? Anyone online? Did somebody call you from Rasmussen Reports or The Economist, Emerson College? No yes is there? No, no. Okay, so they made a prediction based on some data. Who did they ask? How did they come up with that prediction? How accurate do they think that prediction is? Anytime people that collect data make predictions like this, they always can calculate what's called the margin of error. And a margin of error is how close they think they are to the real number if they could have asked everybody. Okay. So here they're making a prediction of a proportion. Let's talk about that for a minute for inferential statistics. I'm going to go, let's see, let's average these two. 51 plus 48, what's right in the middle? 49.5? Sounds right. Here, 49.5% of who? Let's see. Who are they talking about there? Who's the audience? Americans? What's that mean? What does it mean to be an American? You live somewhere in North or South America, right? America's actually much more than just the US. Okay, so they mean US citizens, US voters, people who actually voted. What do they mean? 49.5% of who? Help me out. Come on.
They don't give you enough information.
They don't give me enough information, so we have to guess. So a couple of things to think about. Anytime you see data in the news, there's a margin of error to it. Somewhere there should be a way to figure out what their margin of error was. Like there'll be a link to the fine print where they'll say, how many people did they survey? How did they survey these people? And what they think their margin of error is, how far off it is. We're going to learn how to do this. By the end of the course, we'll know how to do this kind of calculation. So two different things here. There was a sample of people they grabbed, okay, somehow, not physically, right? And that sample came from a population. I want to know what the population here is. So what I would like you to do right now, to the best of your ability, write something down on a piece of paper. 49% of fill in the blank. Who are they referring to? Approves of the president's current job performance. And now you could just write Americans, but then I'm going to say, what the hell do you mean by Americans? What does that mean? I want you to be a little bit more specific than Americans. Write something down. Don't worry about being wrong. I don't know what the right answer is. I didn't calculate that data. I haven't seen the fine print yet. So there's two things I'm looking for: a brief description of who we think the 49% is of, and then we're going to try and elaborate better on what is the population of interest here. So write something down. Don't worry about being wrong, but write something more than just Americans. That's too indescript. It's a great news bite. Most people are just going to say, oh yeah, 49% of Americans, right? I get it. But then if you ask them, what does it mean to be an American? That's a harder question. All right, and then I'm going to pick on two people. I'm going to use my random number generator. Let's see, where's my other screen? Desktop. Hopefully you all wrote something down. And number generator from 1 to, I think we're up to 22 people now. And generate person number 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Haley, hi. What did you think we should fill in the blank with? Oh, okay, that's a good one. U.S. citizens. That how we spell it? I'm good at math, horrible at spell. Spell check saved my life. When I was in college, it was not spell check. It was rough. I had a big dictionary. All right, let's see. Next person. Number 13. So what was the previous number? 10?
Yes.
Okay. 11, 12, 13 is Ty. Hi, Ty. I was hoping for a Zoom person, but maybe next. All right, Ty, what did you think?
U.S. citizens of voting age.
Oh, US citizens voting age. Okay. Whiteboard. Lost it somewhere. There you are. Okay, cool. Couple answers. I think both are good. Both are better than just Americans, because that's pretty vague. America is not just the US. New page. So whether I'm talking about inferential statistics or descriptive statistics, we need to know two things. What's the population? And we almost never have the whole population. What we have instead is a sample. A sample is a very concrete thing. Generally, I have a spreadsheet, and on that spreadsheet is an identifier for each individual in the sample and then information about them. Very concrete, rectangular. Population is very nebulous. It's a cloud. I can see clouds in the sky. How many of you have flown in an airplane? Do you ever fly through clouds? Do you ever feel the airplane touching the cloud when it first hits the cloud? I mean, we get bumpy rides, but can we find the edge of a cloud? I don't think so. Population is a similar thing. Okay, so I'll come back to the presidential approval thing in a minute, but I'm gonna give you two ideas of populations and you tell me how easy it is to identify them. Example number one. Pendleton residents. Sure, that works. Example number two. Squirrels in my neighborhood. Okay. So, let's see. Pendleton residents, is that well defined as a population? I think we can all assume since Blue Mountain Community College, the main campus resides in Pendleton, we're talking about Pendleton, Oregon. That's pretty clear. Resident, do we all know what that means? What does it mean to be a resident?
Got it on your driver's license?
It's not your driver's license, maybe. Like my daughter moved to Rhode Island, but she still has an Oregon driver's license, so that's not quite it, right? And she applied to the community college there. She's been living there for 6 months. They say, sorry, you're not enough of a resident yet. You have to pay out-of-state tuition. Shit, a lot more money. What does it mean to be a resident? Okay, so Pendleton's pretty clear. Resident, I just established, is not so clear. A friend of mine had a friend of theirs moved to town last month. They've been living here a month. Are they a Pendleton resident? They own a house.
Just trying to remember if a month was the time limit or if it was 2.
Is it arbitrary? Who decides this? Right? So my point is, I got a couple points here. One, we see things all the time and we think we know what they mean until we stop to double check. Wait a minute. What does it mean to be an American? What does it mean to be a resident? But at first glance, right, they just slide over us. We just assume we know what it means. And we assume that it means the same thing to us that it did to the person who wrote it. Is that true? Did we all write exactly the same thing down for what it meant to be an American according to that poll? I don't think so. We all have slightly different ideas about that because we all have slightly different experiences. So language is fuzzy, bottom line. It just is. It's really hard to be exact about language, even in math. So we have to come up with a definition of resident. Can't we just go to City Hall and get a list? How many of you gave your name to somebody at City Hall and they know you're living here? Who lives in an apartment here? Anyone? A few people? Okay, who knows you live in that apartment? I mean, you know, your friends know, where you're renting from. Did they tell somebody? Probably not. I've rented places out before. It's just between me and the renter. Nobody else knows about it. So can I find a list of Pendleton residents somewhere? What do you think? Online? Help me out. Yes, no, maybe?
I think you can find it on
Yes.
the Pendleton website
Do you think we can find
because
it?
almost every city has a record of how many citizens they have. Because Hermiston has one.
Yes. Okay. And how did they come up with that? That's a good question.
I think they estimate it through who pays taxes.
That's a good point. Yeah. So people pay taxes. Let's see. And what kind of taxes are they talking about there, you think? Property taxes, income taxes?
I would say income because it makes more sense because not everybody owns property.
Yeah, that's a good point. And how would they get income tax information? Can they just write to the state or federal government and say, give me a list of everybody that had a Pendleton address that submitted income tax statements? I think the IRS gives that away freely. even if you have like an email address that says pendleton.gov. I don't know, right? So my point is, something that sounds pretty straightforward, like Pendleton residents, is not. You cannot find a list anywhere of everyone that lives in Pendleton. Doesn't exist. Even in the smallest town, probably doesn't exist. Squirrels in my neighborhood. That is just as squirrely a piece of information as Pendleton residents, really. These two are pretty equivalent in determining what individuals are in that population. Okay, so this is super important. How do we know about populations? We read information all the time that make these statements, and as soon as we see a number in print, people believe it's fact. Is it fact that 48.9% of Americans approve of the president's job? No. That's a guess based on a sample. Question, was it a good sample? I don't know. I gotta go read the fine print. Just because it ended up in the news does not mean it's legit, good statistical data. So populations are cloudy. It's very rare that you can get information on an entire population. Can anyone think of an example of places we can? Think about this for a minute. I'm okay with silence. I'm gonna be silent. You just think of a population where we actually, yeah, we could identify every single individual in that population.
People attending VMCC.
Yeah, we can get that because to attend BMCC, you had to enroll. To enroll, we have a record, and we can go to the database and print those records if you have the right clearance. Yeah, definitely. Now we have to be a little bit more specific about that. So I might say BMCC student spring 2025, because otherwise it's like, oh, do you mean whoever ever attended BMCC way back in the 60s when it started, they had paper records. Where are those paper records now? They may or may not exist. But this one we could definitely nail. Get every single one. Cool. You ever hear of the US Census? Anybody know what the word census means?
I work for them and I don't know what it means.
Turns out the word census means population. Yeah, it means you have the whole population. Do we ever get the whole population of everybody residing in the US? Well, no, but we get pretty damn close. Like 99.99% of people. We end up getting at least loose information that they exist. Not necessarily an age or other information, but just those people exist in a household somewhere, kind of thing. So population is a census, and censuses are rare. Cities generally don't do censuses, which means they want to try and identify every single resident, but they would have to define resident, right? Like Jonathan said, maybe it's a resident means you've lived there at least 2 months, for example. Some places it's 6 months. It kind of depends. Usually, like, anybody know what colleges use for residency requirements? Usually it's a year, yeah. Like, so I mentioned my daughter moved to Rhode Island recently, so she's not going to get in-state tuition there until she's been there a year. She's got 6 months to go, otherwise we're paying out of state. And some places like BMCC, it's a marginal difference. In some places, it's like triple the amount or double the amount. All right, so this is a place where we could identify the whole population, so we could call that a census. Otherwise, the best we can do is sample. Okay. So for Pendleton residents, the best we can do is some kind of sample. For squirrels in my neighborhood, the best we could do is some kind of sample. It's going to be pretty much physically impossible to catch all of them, people or squirrels, okay? Because they both come and go. So our goal in this class is to learn how to identify the population of interest and end up with samples that are representative. All right, so that's a big question. How does one end up with a quote representative sample? What does representative mean? Anyone?
Represents the population.
Okay, can you use another word besides represents? That's a hard one.
Picture of what the population.
Picture of the population? Okay. Maybe we could say like a snapshot. Shot, there we go. We could say is like. So I have a sample right here in front of me. I have 22 BMCC students. Are you all representative of the entire population of BMCC students spring 2025? I'm shaking. No. Anyone else? What do you think? Online? Egan, Alexis, Monsi, Emily, Emmanuel, Maria, Kimber. Is our class representative of the entire BMCC student population spring 2025?
No.
Answer yes, no, I have no idea.
You'd probably have to take samples of people from our first years and second years and people from different classes, I think.
Yeah. Right, not everybody takes statistics. Okay. There's different teachers that teach statistics. You might prefer to take it from someone else than me. You're all here for a reason. That reason makes this sample bias. This kind of sample is called a convenience sample. You're right here in front of me. So for me to take, for example, the degree intent, and to say 40% of students in this class are getting going for an AOT. Can I then conclude 40% of all BMCC students spring 2025 are going for an AOT? That would be stretching it, okay? Because my sample is probably not representative of the population. So to get a representative sample, usually what we want is a random sample. Random samples tend to be more representative of a population. The only way to get what's called a simple random sample is to have a list of the whole population, and B, use technology to randomly select some. And I mentioned use technology because humans are really shitty at being random. They're just not good at it. We have all these biases that help us survive the world. And those are great, right? We are survivors of survivors for billions of years. That's pretty remarkable, but we're not good at being random. So we can't trust a human on their own to be random, with a few small exceptions. We need some kind of mechanism to make that happen. Classic mechanism before computers was to put a bunch of names on, say, a piece of paper, or symbols on a stone. Each person gets their own stone, their own symbol. Put them in a large vat, mix them up, don't look, pick one out. There's the first element in the sample. Don't look, pick again, there's the next one. If it's well mixed and we're not looking, then we should be able to get a random sample, right? So we could mechanize it that way. Could that be easy to screw up? Yeah, could be, okay. Other ways to get random sample, well, I just went to the internet and used Google's random generator. Can Google be trusted to generate numbers that are random? We get some yeses, we get some nos, maybe some people think, I don't know. As far as computing stuff goes, Google's one of the most powerful forces in the world. So I'm pretty sure that they have some programmers that did a damn good job making sure that this is random and that there's no perceivable pattern to predict what the next number is going to be. Okay. companies that put a lot of research into trying engineer true randomness. Now, what's the problem there? Can humans be random? We have tons of evidence that they cannot. Yet we have humans trying to make randomness. Okay. We're getting better at it. Are we perfect? No. Like 10 years ago, Microsoft got in a big mess because it was found out that their random number generator in their spreadsheet program, Microsoft Excel, was biased towards smaller numbers. Just a little biased, but enough that companies were using that to do special work that required good randomness were getting results they shouldn't have got. It was biased toward the low end, and that was a problem. And they had to work really hard for years to, one, rebuild how they generate random numbers, and two, convince the public that their software was safe to lose because they would lose business over it. Because this idea of randomness turns out is a big deal in a lot of different areas. And let's see, I must have just swiped the screen, ended up in the wrong place. So I'm going to switch over to a different random number generator. And let's see how we're doing on time. We're doing good. We'll take a break in a few minutes. I want to go to my Google Drive. And in my Google Drive, I'm going to open up a new spreadsheet. That's day one for now. Blow this up a little bit. So I just want to demonstrate some other randomness from a spreadsheet. So on a spreadsheet, when you want to do a calculation, and a random number generation is a calculation, if you start typing what you're looking for, I type RAN, I get things like random number between 0 and 1. 0 is inclusive, 1 is exclusive. That means you could randomly get the number 0, but you won't randomly get the number 1. But you get a number really close to 1, 0.999999, however many decimals the spreadsheet keeps track of. So if I select that, close the parentheses and hit enter, it's going to generate a random number. And then the interesting thing about spreadsheets and randomness, every time you interact with the spreadsheet, it re-randomizes anything that was random. So if I do something like, say, that's going to be Gary's random number, as soon as I hit enter, it's going to regenerate the random number. Which sometimes is not good because, oh shit, I wanted that other random number. Well, now I got a new one. And again, every time I use it, equals rand. I get a new random number, and then anything else that was using a random number generator also resets. Okay. Earlier on the computer, I ended up using Google's random number generator here, and I generated numbers between 1 and 22. You can do that in Excel or Google Sheets in a few different ways. I have rand array, which is going to give me a list of numbers. I didn't mean to click it. And then I've got rand between, which is what Google was doing. So for example, I've got 22 people hanging with me right now doing statistics. So I would want a random number between 1 and 22. 22, there we go. And then every time I do something, it's going to give me a new random integer in that case, whole number, counting number. Let's see who is number 20 here. Here, number 10, 13, 14, 15, 16. Okay, got my next pig for a question. Cool. All right. Side note, I just want to see if we can do an experiment that might show humans are not very good at being random, but I want you guys to try really hard to be random. Now, before we do that, I just want to make a note. My sister, I grew up in Rhode Island. Oh, I asked you guys about your degree. Let's take a brief break. I'll tell you a couple things about me. I grew up in Rhode Island, which is a little tiny state on the East Coast. It's about the size of Umatilla County, but there's 1 million people there. I went to community college first because I didn't like the job I had leaving high school and I didn't know what else to do. And I tried to get a degree in business. I succeeded. It took me 3 years. I started in accounting, decided accounting sucked from my point of view. Thought it was really good because my dad was an accountant. And then in the beginning of my 3rd year, I got a letter from the college saying, we're kicking you out if you don't take a math class. Shit, I gotta take a math class? I went to my advisor, I said, what do I gotta take? Well, you're gonna take this business calculus class to get you a degree in business administration. It's like, okay, I'll take it. Well, no, you got to take these other classes first. Turns out I knew how to read, and I read the catalog, and it didn't say you had to, it just said it was recommended. Like, no, I'm taking business calculus. So I took business calculus, and the teacher just blew my mind. He was awesome. Wow, this is fun. This is way more fun than accounting or marketing or all the other business classes I took. And so, like, I'm going to switch to be a math major. So keep in mind that I avoided math for 3 years, now I'm a math teacher. And then I went to the 4-year school after I got my business degree, and I signed up as a math major, but I hadn't really taken any math yet. And they said, okay, you have to take calculus. I said, well, I took business calculus. They're like, no, that doesn't count. Okay, so I took calculus 1. I discovered that there was a thing called trigonometry. Anyone ever taken trigonometry? I had not. And apparently you're supposed to know trigonometry to take calculus. So I had to go to the library and get a trig book. And then after the first test, the instructor wrote, you should drop this class and change your major. Oh, I was so mad. I think I might even cry. That was heartbreaking. I studied my ass off. I quit hanging out with my friends. I stopped working briefly, and I ended up passing the class. And I got an A in every other math class after that, until I got to graduate school and got a lot harder. But anyway, what I discovered there was I liked to struggle, like biking uphill. I think it was fun. And I found studying math was fun. Delayed gratification, and then bam. Not everybody likes that. Okay. Let's see. There was another point to that, and I lost it. Okay, back to the regularly scheduled program. Random numbers. So here I have a decimal number, right? Here I have a whole number, counting number. Okay. Each of those are made up of digits. How many digits do we have to choose from to make a number, a place in a number? 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We have 10 digits to choose from, 0 through 9. So you are going to be a random digit calculator right now. Okay? So what I want from everybody is, let's go for 3 random digits. And again, 20 is not a digit. That's a combination of 2 digits. So 2 is one of the digits, 0 is the other. So what I'd like you to do is write down on a piece of paper 3 random digits to the best of your random digit generating brain. Right now, write them down. 3 random digits. Online. Alexis, Emily, Enrique, Kimber, Landon, Manuel, Maria, Monse, Nick, and Tegan. I need you each to come up with 3 random digits, and I'm going to ask for them. All right, and then you guys got those. Do that later. All right, so that's computer random. This is going to be human random. Okay, so let's see. My random digits are, I think 1's pretty cool. And I've always been fond of the number 7. And let's be a little more random and try 8. Okay. I don't know. Did I do good? All right, so we're going to go around collecting random digits. What do you got? 2, 4, 8. Okay, next. 1, 2, 5. Next. 2, 7, 5. I messed that up there. Okay, next.
3, 4, 5.
3, 4, 9. And over here and back.
8,
8, 2, 1.
6, 1, 8.
6, 1, 8.
2, 5, 9.
2, 5, 9.
2, 7, 5.
2, 7, 5. You got
0, 8, 9.
0, 8, 9. Over here. 2, 1, 4. And then Zoom friends, if you could type them in the chat, that would be delightful. Oh, there we go. Kimber's on it. Good job. Let's see. Where did I leave off? Over here. Okay, next.
3, 8, 5.
3, 8, 5. Okay, over here. 7, 1, 3. Okay, I'm gonna start collecting the online ones, and it looks like I better make that bigger. Where's my mouse? I have too many screens. Okay, so we get there, Alexis on the bottom. We got 3, 5, 6, and then 9, 5, 1. Oh shit, I'm not typing in the right spot. By the way, I make mistakes all the time in class. So if you see me actively making a mistake, say, Parker, Hang on, making a mistake there.
Oh, for sure then, number 31 through 33, didn't you say 2-1
Yeah.
or some shit? Yeah.
Okay, good. All right.
Did I quote you right?
Yeah.
Okay, did I mess anyone else up?
It's 2-1-4, not 2-4.
2-1-4. Now we're good. Okay. Okay, thank you for paying attention. All right, and there are 39 entries and I got 3 each, so it's a multiple of 3. So I think one way to check. All right, back there. 3, 5, 6. And 9, 5, 1. 8, 5, 8, 9. This is harder than you think. Under pressure, you guys are all watching me. Stop watching. Just kidding. 3, 7, 9. 3, 1, 7. Oops. 7. 8, 2, 6. Not sure about the next one. There's the mouse. Here it comes. Okay, so let's see, where did we leave off? 8, 2, 6, 2, 3, 9. 3, 8, 6. 0, 2, 8. Did I miss anything? I think I got them. How many we have? We have 66. 22 times 3 is 66. Okay, I think we're looking good. All right, how am I going to tell if a list of numbers like that is random enough? Well, it's kind of like rolling a 10-sided dice, right? Anyone good at looking at those numbers and seeing, are there, a similar number of 1s and 8s and 0s? 66 is kind of a lot of numbers. What could I do with that? Well, I should apply some summary statistics. Okay. Let's see, what's the most basic summary statistic I can make? Count. So what I want to do is I already counted the total. I got 66 of them. Now I just want to count each one. And it turns out I can do that in a couple of different ways. So first way, I'm going to do it in a super simple way. I'm going to highlight the whole column and I'm going to have the computer count by making a graph of them. So I am going to insert a chart, and we're going to do a bunch of these next week. I'm going to use a chart called a histogram. So Google guessed what I wanted, right? Will it always guess right? No, it won't. I got to zoom out for a second. All right, I need to adjust it a little bit. So, because it picks some weird numbers, 1.9, 2.3, 3.56. What's up with that? I'm going to go for a bucket size of 1. Okay. So this is, the first column is how many times people selected 0. Second column is how many times people selected 1, and so on. Are there any patterns here? Were people likely to select 0? No. Were people likely to select 4 or 6? No. Let's see. Now, again, 66 numbers, that's a small sample size. It's not really very big. What would I expect to happen if I did this a lot more times? Like maybe I asked you guys to give me 100 random digits each. What would I expect to see in the chart if it's truly random?
Maybe kind of flat.
It would be kind of flat. Yeah, I expect to see just as many 0s as 1s as 2s. Exactly the same? No, but close. Now, again, 66 is a small sample size, but we do have some biases. And I've seen this time and time again. A lot of times I get no 0s. For some reason, people just like, I can't randomly pick 0. I got to pick like a number, like 1 or 2 or 3, or I love 7, right? Not as many people like 7 as I did. 6 of you like 7 also. But then again, did you like it or did you just randomly pick it? And how exactly did you determine your randomness? Did one number you pick make you want to pick a different number? Like, did anyone say, oh shit, I just picked 2 even numbers. I should pick an odd next. That's not random, right? And there's tons of unconscious things that we don't even know about that happened when we were picking those numbers. Okay, so point, humans are biased for lots of reasons. We don't mean to be, but it's actually an evolutionary thing. It's helped us survive a lot of things. So we just got to go with it. For a random sample, we need some randomness. And that randomness has pretty much got to be some kind of technology, whether it's basic technology like papers in a bag, or it's some more advanced technology like a random number generator from Google or a random number generator from Microsoft or wherever. We got to use some kind of technology. Back here, I said ideally we want a simple random sample, but a simple random sample requires you have a list of everybody in the population. Do we usually have that? No, we don't. Okay. If we did have a list of the entire population, then we wouldn't really need a sample because we'd already know how to contact the whole population, probably, if we had a list. So we have to rely on samples, which are smaller parts of the population, and then some way to get a random sample, which is often hard. Okay, so we can't do a simple random sample usually. So there's other kinds of random samples out there. So I'm just going to list a couple, and then we'll take a break. Sampling techniques. Okay, so number one is the idea of a simple random sample. Which involves a list and technology. And they're really in no particular order, except simple random is ideal, but not usually attainable. So we try to, come up with some way to make that happen. Other ways we might make that happen is what's called a systematic random sample. And an example of a systematic random sample is some kind of assembly line system. And what you have to do is have some kind of random starting point. And then some kind of random jump. So I might roll the dice or use a computer to say, okay, start at number 7. And then get another random number. And then I would pick every 11th item after that, right? So I would grab the 7th thing, and then 11 later would be 18, and 11 later would be 29, and 11 later would be 30, and so on and so on. Right? So literally an assembly line of stuff going by, quality control, right? We might do something like that. I could use it in other situations. Like, for example, if we were inspecting a road, we could use this in terms of some distance. So we pick some random starting distance and some random jump, and then every so often we stop, we check out the road, how's it doing? Okay. Other places it might come up are power lines need to be inspected regularly to make sure they're working okay. And so we have a map of power lines, and somehow we do a system like this on the map of lines to figure out where to check things, to do some random spot checking. Right? So there's lots of applications to that. You don't necessarily need a list to do it, but it could emanate from a list. But it could also be done without one. 3, stratified sample. Or stratified random sample. And that requires proportional groups. So a place I might use a stratified random sample is maybe grouping people in an area by age. So my groups could be, say, for example, under 18, and then I could do 18 to maybe 25, and then 25 to 30, and so on. And I would have to have some idea of what % of the population is in each of these groups. Okay. If I have no idea, then we just go for equal percentages and hope we guessed right. Okay. But we might have a predetermined guess based on previous information that, maybe this group right here is about 10% of the population, and that group right there is about 5% of the population, and this group is 6% of the population, and so on. So then in my sample, I would want to make sure I meet the quota of having about 10% of my sample being under 18. 5% of my sample being 18 to 25. And you may have received calls where somebody says, oh, could you do a quick phone survey with us? And usually I say yes, unless I'm too busy, because I'm curious what they're going to ask me. And they usually start off with, okay, what's your gender, what's your age, what's your income? And half of the time, once I answer one of those questions, they say, okay, thank you, we don't need you today. Because I didn't meet the quota that they already had somebody like, plenty of people like me in that survey. But every once in a while, they're like, oh, great, we need someone like you. And then they'll ask me questions. Okay. Anyone ever get a call like that and accept it? Yes, no, maybe online? Anyone ever get a call like that?
No.
No? They don't have your number yet, but just because you're not paranoid doesn't mean they're not watching. Just kidding.
That sounds like a threat.
All right, so stratified random sample. So that's a pretty classic one, and often there might be different stratas, right? Like we are going to stratify in terms of income bracket, maybe type of job, all kinds of things we might consider there. And what's the goal here? The goal is we want a representative sample. If we could do a simple random sample, that often ends up being representative if the sample size is big enough. We'll talk about what a big enough sample size is later in the course. But we usually can't do that, so we have to find another technique. All right, number 4 is a clustered random sample. And my best example of a clustered random sample, line this up a little bit. I love digital paper, it's so much fun. Would be a neighborhood or neighborhoods. So we have some town. A lot of times the town is broken up into neighborhoods. Sometimes that's the case of the way development and how the town grew. Different neighborhoods are named. So let's suppose that's our town and those are our neighborhoods. With a clustered random sample, what we do is we randomly select some clusters. And then in those clusters, we attempt to sample everything. So once I pick this neighborhood right there, I've got to do my best to sample every individual in that neighborhood, every individual in that neighborhood, and every individual in that neighborhood. So this might be a way for me to do the squirrels in my neighborhood. So I would block my neighborhood off in terms of properties. And I would randomly select some properties and go say, hey, I'm going to go search for squirrels on your property. Okay. To try and estimate, say, the population of squirrels in my neighborhood. So again, what we do here is randomly select subgroups or sections. Here I have them sectioned out. And then sample all in each of those. Okay, so there are a ton of other sampling methods out there. You can take whole courses in just how to collect samples. And again, it depends on the kind of research you're doing. So I'm going to stop on this one right here. Let's take a 3.5-minute break. It's kind of random. And then we're going to come back and we're going to look at some actual data sets and talk about some things about the data, get an idea more of what data is. So take a brief break. We're light on snacks in the math cafe. I apologize. Hopefully next class will be better. Okay. So get a drink, go potty, stretch your legs, check your social media, whatever you need to do. I am going to, what's up? Oh, I should have ended to me. Okay, I think that's been pretty close to 3.5 minutes. What is next? Let me double check my notes. Okay, we're going to move away from samples for a minute and talk more about data. And then we're going to look at some data sets. So let's go. New page. Data. I mentioned earlier, data is information. And there are many types of information out there. We're going to focus on a couple of types of information. The information we're going to focus on is either what we're going to call categorical. Categorical is some kind of label, some kind of category, some kind of quality. Or it's going to be quantitative. Numerical. Mostly it's pretty straightforward as to which is which. And we need to know this because we can do certain kinds of statistics on categorical that we can't on quantitative, and we can do certain kinds of statistics on quantitative that we can't on categorical, and the types of charts that we make matter. Few cases where it gets a little fuzzy. Sometimes I have to write a letter to somebody and I have to put a stamp on it. I don't do that much anymore because we have email and chat and stuff. But my zip code is on there, 97801, which indicates I live in Pendleton. Right? So the number 97801 is synonymous with Pendleton. So this is kind of a questionable example here. Zip code 97801 equals Pendleton.
Is that quantitative or categorical?
That's what I'm getting for here. Yeah, I'm getting there. I grew up in Rhode Island in a town called Smithfield, and 02917 is Smithfield, Rhode Island. Smithfield. RI there, and Oregon there, because there are other Pendletons and there are other Smithfields out there. Now, it makes sense for me to find like an average age or an average height. Does it make sense to find an average zip code? What would that mean? Other thing is, would I ever list my age as 055 instead of just 55? That would be kind of weird. So like this leading zero over there, like if I type that into a spreadsheet, it's going to ditch it. It's just going to call it 2917 because that is not that zero on that side is not significant when we talk about numerical stuff. So in this case, a zip code is actually a quality. It's a descriptor, like the name Pendleton. Okay. So in this case, I have numbers used as names. So this is categorical. Categorical, there we go. Not numerical. So there are times when we'll come across numbers, but they're really not numbers, they're names for things. So often, for example, when we collect data, sometimes we want to make it anonymous. So what we do is we assign each individual a number instead of using their name. We do that with students all the time, like student numbers. You all have a student number. That student number is used to look you up because names are kind of fuzzy. Somebody could have the same name as you. Okay, that happens. So again, we'll often use numbers as labels. And a label, I guess I should add up. Oh, I did already put a label up there. Yeah. That, like Pendleton is a label for this place. 97801 is another label for this place. They mean the same thing. Whatever we designate as this current place as a town. But usually if you see a number, it probably is a number. But every once in a while we have to ask ourselves, oh, wait, that's actually a label, not a number in this case. Did you ever do a survey and you had to rank like 0, 1, 2, 3, 4, 5? As like 0 means you suck and 5 means it was awesome, or they suck, or whatever it was. Yeah. that is kind of a number, but it's using a number in a ranking kind of way. It's different than a height, for example, or an age. And so that is, it's kind of a label because 0 is attached to a meaning and 5 is attached to another meaning, but there's some rank involved. So that is kind of in between, but it's more quantitative than categorical. Okay. So mostly it's pretty obvious which is which. Once in a while, there's weird cases like zip codes, like student numbers, and like ranking systems, because those are kind of arbitrary and then labeled. Next. Data is usually from a sample. Is usually in a table or frame. And in this case, the idea of a table and a frame are synonymous. There are rows and there are columns. Sometimes the rows are called cases. They are usually the individuals we're referencing. And going back to my earlier examples, an individual could be a human, it could be a squirrel, it could be a place like Pendleton, it could be a whole country like the US. And the columns are usually variables. Variable is specific information about each individual. Like if we're talking about students, it would be, say, your age, what degree you're taking, what year you're in, how many credits you've accumulated, what's your GPA, all kinds of things like that. If we're talking about something like Pendleton, then it would be like average elevation, population, area of the city, other resources that the city has. Every city has slightly different populations, slightly different areas, or maybe vastly different areas. And so those characteristics vary about individuals and about cities, for example, or squirrels. Those variables, again, are either going to be categorical, or they're going to be quantitative. And sometimes you'll see quantitative referenced as numerical, and sometimes you'll see categorical referenced as qualitative, because it's a quality of something. That quality could be just a name. All right, so I'm going to look up a couple of different data sets now. If you happen to have access to a computer, cool, get it out and you can play along. Otherwise, you can just watch. The next class, you will need a computer. I always bring extras in case you don't have one, because the next class, I'm going to have you do some stuff based on data. But here, I just want to show some data and talk about it. So I'm going to start off with some data that I'm collecting. So there's this data collection assignment that I want you to do soon. And I can see 4 people have already done it. So what I have here is an anonymous survey that you're going to take. Now, because it's an anonymous survey, I don't know if you took it or not. So to tell me you took it, there will be a submit button or start button at the top. You're just going to tell me 2 of the questions you answered on the survey. Oops, I did not want to edit that. I just accidentally touched the screen. Cancel. Okay, so I'm going to just take a quick look at the survey here, and then I'm going to look at some of the data. So again, I'm not asking who you are here, but I would like you to give an honest assessment of your age, gender classification or not, hair color, eye color, height in inches, weekly income, usual hours slept, blah, blah, blah. I'm just going to ask a whole bunch of information of you. Give your best answer for each of those. The data is visible here. So this is where the data comes in. There's a tab at the bottom that says form responses 1. So every time somebody fills out this form, then their information gets appended to the bottom automatically, which is pretty cool. I like Google Forms. So at this point, I have 473 individuals have filled this form out. Notice I say 473, but down here it says 474 because there's titles at the top of what each one was. Okay. In a spreadsheet, when you have data, you can't always rely on the row number to give you a count for a variety of reasons we'll see later. So somebody figured 19-year-old male with dark brown hair and brown eyes that's 68 inches tall filled this out. Okay. So this is a data frame. Each row is an individual, and I have information about that individual. There's a timestamp. Now, again, each column is a variable. Would you agree? Age varies among people. Yeah. How people identify their gender varies among people. Heights vary among people. Eye color varies among people. Information we collect from any individual, whether it's a squirrel or we're making hammers, right? Things vary a little bit. If you were at a plant and you were making hammers, is each hammer really exactly the same weight? Nah, there's a little variation that goes on in the construction of anything, right? There's always variation. Things are not the same. Impossible. So statistics, part of what we do is we measure variation in things, right? And that variation can have different meanings. So that's, again, one of our goals, learning what the hell does he mean by variation? And we'll get more used to that idea as we go. But first idea, this is a data frame. When data is collected, it is eventually put into some spreadsheet like this. A spreadsheet is sometimes a data frame, depending on what you put into it. And it's also a data table. Generally, it's organized where each row is an individual, each column is a variable. Now, can we get information just by looking at a data table? Not much. I mean, we can kind of get a count if they're enumerated somewhere, but otherwise it's like, it's vomit. It's a ton of shit that I don't know what to do with, right? This is why we need things like summary statistics. Like, what's the average age? What's the usual age range of my students? Wait a minute, what do you mean by usual, Gary? Like, don't we hear things like that in the news all the time? Well, the usual age of students is between 25, let's say 20 and 25. And we're like, oh yeah, that makes sense. Wait, what do you mean by usual? So one thing I hope you get out of this course is anytime you see data in the news, you're going to stop and think, oh, what do they really mean by that? Right? Because it's not always obvious. All right, another one. If you happen to have a device with you, you might want to try this with me. Let's see, useful websites. The book has a website that goes with it. So here I have a print copy of the current book. You should have paid a fee that automatically gives you the book through the Vital Source course materials link. Since I'm not a student, I can't check that, but if you go there, you should get an option to get to the ebook because you paid for it with a fee for this class. I don't know about you, but I spend way too much time on the computer. So I like to print things once in a while to just do something different with my eyes and my brain. So you could get a used copy of this one, or the previous edition is pretty damn close, inexpensively online. So if you decide you need a break from computer shit, then I highly recommend getting a cheap print copy somewhere of the actual textbook. The website that goes with the textbook, this one here. Yeah, I have a link to it right here. They have a shitload of data sets within recent history, and we're going to play with these. Like every week, I'm going to grab one of these and do something with it. And sometimes I'll bring my own data sets I'll found somewhere else. So for example, I'm going to pick one of these. I want to check out all countries. And typically the CSV, which stands for comma separated values, or the XLS file is what we'll go for. I usually go with the CSV because it downloads quicker and all spreadsheets recognize it. So I'm going to go grab that one.
Made by 5 people with the last name Locke.
Oh yeah, that's funny. Okay, so let's back up a second. The website is called Lock5Stat because the authors of the book are a family of statisticians. So the mom and dad are professors at these East Coast universities, and 3 of their kids went on to get degrees in statistics. 2 of them teach at major universities somewhere. One of whom I know is at Penn State, and I borrow stuff from him all the time. He's got great stuff. And the other sibling is actually the head statistician for the Miami Dolphins. And the five of them wrote this book. And it's like the best stats book I've ever seen because they do a really good job of using real data to do statistics instead of made up shit, which is nice. So pretty much everything we're going to do here is real data. Even if it's like convenient data from you all, it's still fun to play with. All right, so let's see. I think I just downloaded that. I didn't even check. Yeah, they're like I have a degree in math. Half the people I get degrees in math with teach, and the other half work for some organization. Sometimes it's, you know, a sporting place. Sometimes it's places like Microsoft and Google. They like people like me that can do math to figure shit out. All right, so so what I have to do to use it, I have to download it first to my computer, and then I can go into my Google Drive and upload it. See, there's my Google Drive, new file upload, and oh shit, I forgot to pay attention where I put it. Probably in downloads. Yep. And then I tell Google to open it. And usually if you're a Google user, whether it's a CSV file or an Excel file, you'll want to convert it to a Google file. And that's slightly different steps depending on whether you're using an Excel file or a CSV file. But this allows me to use spreadsheet tools on it. Okay. So here I have another data set. This data set is a table or a frame. The frame has rows representing individuals. Individual what? Individual countries. Okay. So again, we're not always talking about a case as a human. A case could be a country. A case could be a hammer if we're making hammers, or squirrels if we're studying squirrels. So here we have a country name and a country code. We have land area, population density, GDP, gross domestic product. Sometimes that information is missing, right? For some reason, whoever collected this data couldn't get that information reliably. So we'll find things are missing. So when I'm looking at, say, a count, there's going to be a count for the whole data set. So like if I highlight that column right there, it's going to say on the bottom right, it counted 218 items in that column, one of which is the word country, which means I have 217 countries to look at there. But if I look at the count for GDP, it's going to be a little bit different. There it's trying to add them up. So bottom right corner, by the way, you can do quick stuff. And usually it's like average, sum, count. So 188 entries, ignoring the word GDP, that would be 187 countries we have the gross domestic product. Gross domestic product is something you might hear about in the news. What that is an estimate of the value of everything bought and sold in your country. So it counts things like TVs you buy, food you've purchased, haircuts you got, right? Any transaction is part of our estimate of what gross domestic product of a country is. And another thing about gross domestic product, just for fun, is have you ever noticed like the value of a dollar versus the value of, say, a euro or a Canadian dollar? They shift. Sometimes US dollar is worth more, sometimes it's worth less. That is partially based on how the gross domestic product of those countries change with respect to each other. Okay. There's other things that influence too, but that's a cool bit of economics that come from data. So the values of dollars versus euros are dependent on data economists collect all over the world and trades that happen related to that. So let's see, land area. What kind of data is that? Quantitative, qualitative? Is that like the name of the country, or whether the country like has a president or a dictator, or is that something that had to be calculated? That had to be calculated, right? So it's a number, it's a calculated number, so it's numerical or quantitative data, right? Is there much on here that's not? Well, we have the country and the code. That's definitely not numerical. Those are qualitative or categorical. Rural. What does that mean? Shit, rural.
So like rural population.
I don't know. Military? health? Shit. Can you tell what a variable is just by looking at the name? No. Okay. Land area. How do we measure land area? How do you think we measure it in the US?
Acres or square miles?
Acres or square miles? I think square miles is more common. Does the rest of the world use miles? I think we're the only country in the world that uses miles right now. I think we're solo on that. I think no other country. It used to be we were like 3 other countries and us use miles and feet and shit. Now I think we're the last holdout. What are these? Square miles? Are they hectares? Are they acres? Are they square kilometers? I don't know. So this is super important. Anytime you look at a data set, you also have to have a data set description. Okay, do I have that here? Okay, where do they get the data? Block 5. So somewhere here, there should also be a description of the data. I didn't see it at the top. Oh, documentation for all data sets. It's a PDF file. Sweet. Ooh, and it's in Russian or something. Interesting. All countries, page 5. Okay, I've actually typed page 5 here to get there. All countries. All right, so let's see. Land area is in thousands of square kilometers. Aha, so it's not just square kilometers, it's thousands. So we have to tack 1,000 onto every one of those numbers. Rural, percent of the population living in a rural area. Oh, duh, of course. But wait a minute. What does it mean to be rural versus not rural? Shit. So again, something that happens to me all the time, I look at a data set and I'm like, oh yeah, I know what that means. Oh, do I really? And then I look it up and I'm like, oh yeah, I get it. Oh shit, I don't know. And if I have this problem, you're gonna have this problem too. So one of the biggest things I see in this class, you're gonna get really good at calculating statistics and making graphs, but through the whole course, what's always gonna be a struggle is being sure what the variable means and being sure what the population of interest is. Those are always going to be hard to figure out because language is not always clear. And then we take for granted things like rural. Yeah, I get it. Pendleton's rural, not compared to Athena, right? It's all a matter of perspective. So definitions often have to be looked up further to figure that out. Okay. So again, point of this right here is when we collect data, we usually end up with that data in rows and columns. Each row is a case or an individual. Each column represents a variable, which is specific information about each case, but it's always similar kind of information in a column. Because it ends up being in a table, there's always a short descriptor. It's not always obvious what that means, right? I think area, yeah, I get area. There's an area on the floor. The college has an area. Pendleton has an area. But how did they measure it? What are the units? So anytime we have a data set, we also have to figure out where's the description of that data, okay? Because it's not always going to be obvious. Let's go back to one more example, and then we are out of time. If I look at the average student survey, height in inches, that's pretty clear. But did the people that filled this out always give me height in inches? Answer is no. I got some interesting things in there that when I tried to look at the data, it did not compute. Something didn't go right. Usual hours of sleep in a night. Would everybody interpret that the same way? Is that pretty clear? Usual. What do you mean by usual?
What are you measuring it by?
In a night? Well, what if you sleep during the day? Shit. Oh, this is getting fuzzy again, right? Sometimes things are clear, sometimes they're not. It's really hard to be clear. Eye color. For that one, I picked the eye. I gave you a selection of eye colors. For hair color, you could type whatever the hell you wanted. How is that going to be to analyze? People could type anything they wanted. That's going to be hard to analyze. So sometimes raw data needs to be scrubbed in order to analyze it. Scrubbed could mean a couple of different things. There's just bad data. Like somebody typed a 5 in here. Did they mean 5 feet? Did they meant to type 50 something and didn't type it? I don't know. Okay. So again, data collection, even if it was by professional, you'll sometimes get data that's just weird. You got to figure out, do I chuck it? Do I modify it? Okay. it gets complicated. All right, I think I'm ready to stop there. So we have covered 2/3 of chapter 1 and a little tiny bit of chapter 2. So what we're going to focus on next class is all the things I didn't quite get to in chapter 1. I'll make sure I tag those, go over them. What you should do in the meantime is get in there and start reading chapter 1. At the very least, skim it and then start taking some notes. So I do expect you to take notes in a class like this. If I write something, if I take the time to write something on the board, you should take the time to write it down too. And then when we're playing with data, I will tell you when I need you to play with me. So for example, next class, we're going to get at least 2 data sets and we're going to do the same stuff to those data sets together in class. Okay. So come prepared with a computer. If you don't have access to a computer to come to class, I always have extra laptops. I can hook you up. If you have any questions for me, track me down after class or send me a note. And otherwise, have a fantastic day. And I look forward to playing with you some more on Thursday. Thank you all.
Thank you. Have a nice day.
You're welcome. You too.
Hi, you open for questions?
What's up? Yeah.
On the Canvas page, on the Vital Source course materials, the
Yep.
book doesn't show up for me.
Does not. What do you see there?
Whenever I enter it, it says you currently have no materials associated with this course.
Oh, shit.
However, I did get an email that said I did have access to it. So I don't know where the discrepancy showed up.
Okay, hang on a second. Oh, Luke, what'd you say?
I was gonna ask if the textbook was like automatically applied to our account, like the inclusive access charges.
That's what I thought it was.
Or if we were supposed to go and purchase it.
Did you see an inclusive access charge when you registered?
Didn't look because
didn't
my
look.
other 2 classes were inclusive access, so I was just assuming that this one. was
Yeah,
too.
so my intent was that this was supposed to be inclusive access. Whether that truly happens or not, sometimes really does and sometimes doesn't. I had checked in on it 2 weeks ago and somebody assured me it was. But given Landon's problem right now, either he's having a problem or I am wrong about it.
I can
So
double
we'll
check
sort
when
that out.
I get home and then I'll send you an email.
Yeah, check on it when you get home and let me know.
All right. Have a good
Okay.
day, Gary.
You're welcome. You too.
Yeah.
Yeah, so Landon, it is unknown at the moment. Do you remember seeing a charge for inclusive access for this course when you registered?
I can check here in a moment, but I did get an email
Yeah,
right on March 31st
yeah,
saying that I do have inclusive access to it.
okay,
And accessing that link that provided in the email, it does say I have access, but to access it directly, I have to go to the course dashboard on Canvas, and it doesn't show up there.
okay.
So I think it's just a Canvas issue, if I had to presume.
Yeah, and it's not going to show for me because I'm not a student. I currently have no materials. It was about to show and then it disappeared. Okay, I will follow up with Vital Source next. Did they, in that email, did they give you a link to Vital Source to log in and see it?
Sort of. It says in captions right below the actual textbook,
Yeah,
to access your content, please go to the course dashboard in your learning management system.
okay. Yeah, that would be that link, the Vital Source link. So I know in other classes, my students had trouble getting to it there at first, but there was a way for them to get into Vital Source. I wonder, does that take me to an outside page? Remember, there was another link somewhere else. None of these links work. Error. Okay. I will look into it and get back to you.
All right, thank you.
Yeah, thanks for letting me know, Landon. Bye-bye.
Bye.
Have a good day. I was also going to ask a similar question, but here it
You
is.
weren't able to get to it either?